Without Renderdoc, modern graphics debugging would be way more stressful. That's quotes coming straight from AAA teams, like DICE and Activision. Renderdoc is one of the most trusted graphics debugger in the industry. And at the end of this video, you will know what Renderdoc is and how it works, how to spot issues and debug with Renderdoc, and how to set up Renderdoc and capture a screenshot. Also, as a bonus, in the end I will show you how to make the workflow so much easier, getting rid of boring unnecessary steps and instead linking directly to your application. Even though being a main pillar of graphics debugging, it's barely mentioned and quite often taken for granted that everyone knows it, which is exactly why you need to learn it as well. Renderdoc is a lightweight, free, open source graphics debugger. It lets you take snapshot of your graphics pipeline at any moment and replicate exactly what is happening in your code. You can change settings in real time to see how different choices affect the result, which makes it easy to spot and sometimes fix problems right inside the app. Renderdoc has tons of features, so let's start exploring them. The main tabs we will work with 90% of the time are Event Browser, Pipeline State and Texture Viewer. But let's first quickly check out the Launch application window, as this is where every Renderdoc workflow starts. Here you'll set the location of your executable and working directory. If needed, you can also add command line and environment variable. The window also has capture options, most of which you probably won't use, but two important ones: lets you capture multiple frames and queue capture at specific frames. Honestly, this setup can feel repetitive and boring. That's why later I'll show you how to integrate this directly into your application for a smoother experience. Now let's move on to the good stuff. The Event Browser shows everything sent to the GPU, like draw calls, compute dispatches, and resource bindings. It's like a timeline or list of steps of the entire rendering process. When selecting one of the event, realize that all the other windows change to view that specific event, which helps you isolate that problem. To make debugging easier, add markers in your code, using things like ID3D11 user defined annotations or equivalent. You can also use set private data on resources to name them. In the event browser, you can also toggle time duration to estimate how long each call takes. Although take this with a grain of salt. You can filter event to quickly find what you need. I use the action filter 90% of the time. Add bookmarks if you need to find back to a call easily. This is especially helpful when the list gets long and cluttered. Now that you've seen how to navigate in the event browser and find specific calls, the next step is figuring out what actually happens during those calls. That's where the pipeline state window comes in. It's like looking under the hood and see how the GPU was configured at that specific moment. If you want to dive deep into each stage, check out my other video. For now, let's focus on what Renderdoc can show us, starting with the input assembler. The input assembler shows how and if your model gets assembled correctly. It shows you your input layout expected from the currently bound vertex shader and the actual data sent from the CPU. It shows buffers like vertex, index and instance buffers. You'll also see a visualization of the primitive topology here, maybe taking up a bit too much for my liking. The mesh viewer though is one of the best parts here. It previews the assembled shape from the vertex shader's perspective. You can toggle between VS input, the raw data, and VS output, the clip space transformed and ready for the pixel shader. You can switch between arcball and flycam for different views. And another view that's useful is the hold pass, which lets you view the primitive isolated in a view of the entire frame. Toggle between various visualization modes to see it easier. If we move our attention upwards, here's a table of vertex data, showing both input and output with semantics. This is where you can spot errors with vertices, transformations, or instancing. If you're doing instance rendering, you can view all of your instances here. The sync view toggle is almost a must here, as it helps you sync from VS input to VS output. Finally, if you're using geometry or domain shaders, you'll see their output in a similar view. Let's follow the flow and look at the vertex shader stage. At the top, you'll see the vertex shader itself. If it's compiled with debug info, you'll also get the name and can even view the shader code directly. One of Renderdoc's best features is the ability to edit shaders. You can tweak the code, update it, and instantly see how it changes the frame. This is perfect for quick debugging and testing fixes. Just remember to compile your shader with debug flags. Every resource in Renderdoc is clickable. This means you can inspect how a resource was created, which helps you a lot when tracking down errors. Below the shader, you'll find 3 key areas: resources and samplers. Although not as frequently used, they can still be used in the vertex shading. We'll cover these more in detail during the pixel shader stage. Constant or uniform buffers. Clicking the green arrow opens a detailed view. These show you all your constants and their current values. The next 3 steps in the pipeline are hull, domain, and geometry shader. Hull and domain, together with the tessellator, are the 3 stages used in tessellation. Hull and domain are programmable, whilst the tessellator is a fixed stage. I don't have a lot of experience debugging these, so if you have any, let me know in the comments. But looking at it, it will mostly give you the same information as VS and PS, with some extra tessellation properties. Geometry shader stage. Just like the vertex shader, the geometry shader outputs vertex data to the pixel shader. Raster state. This helps you debug the viewport and scissors. This is especially important if you have multiple render targets, and if you have a viewport or a scissor that are different size than the actual render target. Here you will also view the important Rasterizer state, which shows you data like culling mode, anti-aliasing, and depth biasing for shadow mapping. Pixel shader, where you probably will spend most time at. Here we can view the resources, which is all of the input textures and arrays that you can sample and load from in the shader. The samplers are used when calling the .sample function in your shader. It tells you how to interpolate when doing texture sampling. Constant buffers are also viewed here, just like the vertex shader. If a resource or a constant buffer doesn't appear, that you know is bound and even declared in your shader, that usually means it's not used in the shader. Viewing and debugging the resource's layout helps a lot with making sure it has the correct layout you wanted, as well as seeing if it has too much data that you do not want, which can help you with optimizations. You can also see if and what compression it has. The pixel shader is also viewable and editable. Another trick can be used to debug a specific pixel, but more on that when we arrive at the texture viewer. Output merger. The last but might be one of the most important tabs. Here we view things like the output render targets and URVs, blend states for various render targets, the depth and the stencil state. At this stage, the best way to debug is taking a quick glance at the previews and clicking on the green arrow to see how the state was created. Compute shader. Take note that the arrow is not connected to the pipeline, and the visualization is correct because the compute shaders aren't part of the graphics pipeline. This means we cannot directly forward data from or to other stages. They exist and get inputted in different queues. Because they do, try to always group together compute shader tasks. Viewing a compute shader is a little bit tricky. If you have a full screen effect, it's pretty easy though. Just input a pixel position to get a specific pixel. Now for the texture viewer. This is the window that you will have open and look at the most to see why things aren't looking the way you want. The main thing here is toggling between input and output in the side panel. To view the input textures, output render targets, and the depth buffer. Some toggles and buttons that you should know about are the RGBA toggles, black and white point, drag and magic wand, especially good when looking at the depth. The depth and stencil toggle to view the different parts of the depth stencil render target. MIP maps can be viewed and toggled here, as well as slice and face if you have a 3D texture or a cube map. And the overlay dropdown. Here are things like highlight draw call, wireframe mesh, depth test, stencil test, and backface call to see if things goes through or not, and overdraw modes to see how much overdraw you got. If you right click on a pixel, the pixel context in the bottom right will pop up. Debug to view that exact pixel in the current events pixel shader you have selected. The history, on the other hand, lets you show all the events that specific pixel have went through. This is great to spot if and why you might have a lot of overdraw in your application. But speaking of making things easier, Now I want to show you how to make your Renderdoc workflow much easier. No more repetitive, boring launch application steps. This will save you a ton of time, whether you're working with your own engine, Unity or Unreal. Let's first show you how easy it is to integrate Renderdoc in your own code. First we head to Program Files, Renderdoc, and grab the Renderdoc app.h and put it next to our other files. We then head into code and make an init function. We find and grab the DLL in the Renderdoc path we just were in with the load library A. The reason we didn't just grab it as well was because if we update Renderdoc, we would need to grab the updated DLL each time. But feel free to do that if you want. Just put it next to your exe. Next thing is initializing Renderdoc. And that's it. It's so easy. Just make sure you call the init function before you create your graphics API device, such as a D3D, create device and swap chain. Now for Unity. It's just so insanely easy. In your game window, press the 3 buttons and click load Renderdoc. Then press the camera and there we go. And lastly, for Unreal, you will have to install the Renderdoc plugin. Once installed, similar button to Unity will appear, which does the same, takes a screenshot. Renderdoc has tons of features, but these are the ones you'll use the most. It's super important to understand this tool, not just for debugging, but also for finding ways to optimize your work. But spotting bottlenecks and optimization opportunities in Renderdoc is just one side of the coin. To truly improve your graphics application, you need to know how to optimize and what techniques to use. That's why you should check out this next video where I break down 50 optimization techniques commonly used in game development.